once. Okay, so we are live, I guess. Ignore the background, please. I'll just type it in. Ignore the background. Oh, man. Hi. Let's see how this goes. Let's see how it goes. Ignore the background if you can, please. Yeah, so let's begin. So, what are we gonna do then? Just quickly share my screen. So, what are we doing today? We are going to do DSA. Target is three problems in this session. Like, I'll do the live for like our target is solving three problems, and I'll tell you about what this current screen looks like. So, we have a lot of AI models and a lot of AI tools now. So, what I do is, let's say I want to start DSA. I asked it, like I gave it a prompt to build me a like kind of a book that highlights all the patterns that the DSA has, all the details that it has, and how should I start solving the problems to build intuition for the longer run. Like अगर मैं मतलब कैसे मैं प्रॉब्लम्स को अप्रोच करूँ, कैसे सॉल्व करूँ ताकि मैं आगे विन इन इंटरव्यू, लाइक कोई अगर इंटरव्यू दे रहा हो अच्छी कंपनी में, और समथिंग दैट इज नॉट पार्ट ऑफ लीड कोड, लीड कोड से नहीं है बट इनवेरिएंट है सब ऑफ वन ऑफ द प्रॉब्लम, इट्स रिलेटेड टू वन ऑफ द प्रॉब्लम. तो आई शुड बिल्ड द इंट्यूशन लाइक कि मैं कोई भी प्रॉब्लम को आराम से इजीली सॉल्व कर सकता हूँ, नॉट जस्ट द प्रॉब्लम्स आई हैव सॉल्व माई सेल्फ बट एनी प्रॉब्लम थ्रोन एट मी. So I use the Copilot, give it a prompt to generate me a book from for all about all the patterns that we have. What are the ways to identify them? Like if you say arrays and two pointers, like it has a readme.md that explains about the two pointers and the arrays, how they're stored in the memory and what not. There is a cheat sheet. There is what the common mistakes that people do. There are some diagrams, like yeah, this is the way the two pointer moves. There is a two pointer converging two pointers, one pointer at one end, one pointer at the other end, and they start moving towards each other until they reach like towards each other. Yeah, then there are some exercises, and like they map to the lead code problems. And there is this how you build into intuition, like why sorted array is so powerful. An unsorted array is like a warehouse where items are placed randomly. Like if you say, like there are a lot of quick commerce like Zepto or Instamart or anything, like they have a huge warehouse. They are putting a lot of items in there. Now suppose I'm working there and the items are placed anywhere, like not in any order. Like a s- any item could be placed anywhere. A coffee could be placed at the end of the warehouse, and an umbrella could be placed at the start of the warehouse. So I don't know where to find, like, and they are scattered everywhere. So what would happen, like if I want to search for something, like let's say I want to search for coffee, I'll have to start from the front and go to the end, and it's going to take time because I would be looking at all the items in the meanwhile. Like मतलब अगर आप उसको समझो कि अगर कॉफ़ी लास्ट में रखा है और आपका अम्ब्रेला मतलब कोई एक सामान आगे रखा है, जब आपको कॉफ़ी ढूंढना है तो आप अगर कॉफ़ी ढूंढ रहे हैं तो आपको हर एक सामान को देखते हुए जाना है और एट द एंड जाके आपको कॉफ़ी मिलेगी. दैट्स व्हाट वी कॉल इन कंप्यूटर साइंस लीनियर सर्च. लाइक आप लीनियरली आगे बढ़ रहे हो और सर्च कर रहे हो, देख रहे हो कि कहाँ है कहाँ है कहाँ है कहाँ है, फिर आप जाके वहाँ पे आपको कॉफ़ी मिलेगी. इंस्टेड अगर वो सॉर्टेड ऑर्डर में होता, लेट्स से कि ए से स्टार्ट होने वाली सारी चीज़ें एक जगह, फिर बी से स्टार्ट होने वाली सारी चीज़ें एक जगह, फिर सी से स्टार्ट होने वाली सारी चीज़ें एक जगह, ऐसे करके ए टू जेड आपका सारा सामान पड़ा है, तो आपको पता है कि आई डोंट हैव टू लुक इनटू द ए और बी और beyond C for a coffee. I just have to go to the rack where C item starting with C belongs. वहाँ पे मुझे कॉफ़ी मिल जाएगी. So that's going to take much lesser time. You are just iterating three times. Like you have to do, like you have to cross A, you have to cross B, and the C is your destination. Otherwise, you have to go to the last of the warehouse. So you don't want to do that. Like don't waste most of the time when you are doing quick commerce, right? Like 10 years later, if a person orders 10 items, that's India. So you know, delivering in 10 minutes. So this is like intuition, how you build intuition, and how there is another chapter like recognition, like how you recognize if it is a 2 pointer. So there are a few things that says that like, there is a strong signal if it says find two elements in a sorted array that satisfies the condition. That's a two sum with sorted array. So these are some recognition points where you can understand. Yeah, that's okay. Okay, this is 2 pointer. So these are all, seven book, like seven within a chapter. There are seven books, like seven small micro chapters that teaches a different thing in phone. So that's what I have built, and I have put it on my GitHub account. You can, like, you can look at it anytime, and I'll just share the link of it. And, I'll just share it here. I'll quickly go to DSA. Yeah. So if anyone wants to have a look, or anyone studying DSA, will keep this. Check it out. It's helpful. Or let's okay, then let's start without wasting our time. So the first is this algorithmic thinking handbook. The name is that algorithmic thinking. An expert is not someone who has memorized all the answers. An expert is someone who has understood the questions deeply enough to derive the answers themselves. What this book is, this is not a pattern memorization guide. It is not a list of tricks to apply blindly in interviews. It is a structured journey through how humans naturally discover algorithms, starting from real world problems, reasoning about inefficiency, and arriving at elegant solutions the same way the original inventors did. By the end of this book, you will not know algorithms the way you memorize multiplication tables. You will understand them the way a master carpenter understands joints. Deeply enough to improvise, you understand their approach in okay, yeah. So who this is for? A software engineer who can write code but wants to think faster and more clearly about hard problems. Instead of forgetting patterns, the night before an interview and all blah blah blah. So every abstraction in this book is earned. We never introduce an algorithm before you have felt the pain it solves. We never show you a data structure before you experience the limitation it overcomes. We never state a time complexity before we have derived it together from the shape of the world. This is how understanding is built, not with flashcards, but with friction and resolution. How to read this book? Read chapters in order, like every chapter built on the mental models introduced before it. Do not skip to the chapter that seems relevant to your interest. The power of this book is cumulative. Like you know, what does it mean? Like you have to study, मतलब आपको एक chapter by chapter पढ़ना है. एक chapter पढ़ लिया आप. The second chapter is built on top of that. Like that's a stack. समझो, मतलब एक ये है, इसके ऊपर एक ये है. So this is your chapter one, and this is your chapter two. Unless you don't understand chapter one, you don't understand chapter two. So you have to study chapter one, internalize it, like understand, मतलब आपको समझना है उसको अच्छे से. Then you go to the chapter two, and then you go to the chapter three, and then so on. This is a fairy tale that you end up in. Yeah, don't randomly jump on chapters if you think they will interview about that. A reader who has worked through complexity and arts areas enhancement will understand dynamic programming in a completely different way than someone who jumps straight to. For each chapter, read the story. There is a story, like a real-time story. Actually imagine yourself in the scenario, try to solve the problem before reading the solution, and when you see the key observation, pause. Verify it makes sense to you before moving on. Do at least one exercise before reading the next chapter. The universal problem solving. This is the framework that it has developed. This is the only thing worth memorizing. Like this is we have to improvise, memorize. That this is I have to follow. And these are the chapters. So note and code. Every algorithm in this book is a note and code. The book does not teach you, the class teaches you to think. Like I'm trying to build a think. Going to how to pass into. I have to build the thinking on how to use this book. Wrong way to use it. Before anything else, let's be honest about the wrong approach because it's the most tempting one. The wrong way. Open a chapter, read it, think, yeah, that makes sense. Move to the next chapter, repeat 70 times, and you create panic in the interview. This fails because the conclusion is not recall. Reading a clear explanation feels like understanding. It isn't. I have, yeah, I don't, मैंने बहुत बार किया है। मैं कुछ पढ़ रहा हूँ and when I'm reading it तो मुझे लगता है कि वाह भाई सब कुछ समझ आ गया भाई अब तो कुछ करने की ज़रूरत है नहीं but I think without practical knowledge like doing anything practically like without writing a code if you are a software engineer without writing a code आपको मतलब बस पढ़ने से कुछ नहीं आएगा भाई जब तक आप एक प्रैक्टिकल कोई चीज़ नहीं कर रहे हो यू आर नॉट गोइंग टू फीड दैट इनटू योरसेल्फ सो even if you are learning the smallest thing in the world then if you are starting JavaScript start writing like write the code put the debugger understand how the context is created how the lexical environment is created how closures work how this works and all about that like put a debugger on every program that you are writing try to write some complex programs use closures use this use arrow functions use understand lexical environment, understand environment, execution context, understand the call stack, understand the heap, and and you become better every day. Yeah. So, so the wrong way is that open a chapter, read it, think, yeah, that makes sense. Move to the next chapter, repeat 17 times, and feel prepared. Panic in the interview. Yeah. Come on, everyone has panicked in the interview. Yeah. So the right way. What's the right way? A weekly system. So there are three ways. It says there are three ways, but you can take it up on your own, like the way you want to study. It's not necessarily or entirely that you have to follow everything here. It's just the way it says you should be. So the handbook is designed to be worked through three phases. Like the first one is foundation. So that's going to take around 1 to 4 weeks. Build the mental models, one chapter per week, focus on understanding, not solving. Phase two is reinforcement. Solve problems, apply what you have built, struggle in mandatory. You would struggle, you know. तो मतलब जब आप DSA या कोई कॉम्प्लेक्स प्रॉब्लम सॉल्विंग स्किल को टारगेट करोगी you will often struggle like not just one time but every time you are gonna struggle like even on the easy problems or the medium and the hard ones are like always struggling so even on the easy problems you are gonna struggle in the initial days what's more important is that you are not giving up and you are solving it anyway like you are doing it you're killing it yeah so don't be afraid to struggle keep doing it yeah and the third phase is integration, like you start solving unseen problems. Like I have solved around 380 problems on lead code now. But I'm trying to start from scratch. I know I would be able to solve the problems that I've solved, let's say 10, let's say 5 times. On my own problems to solve them more easily, but I'm gonna try to write them down in the framework that it's set. Like I want to build the intuition, not just memorization, not work on memorization, but yeah, I have to build an intuition. Like you can throw any problem at me, and I'll be able to solve. Yeah. So the phase one is for each chapter. Follow this exact sequence. No skip steps. Read the chapter's opening story. First section of the readme.md. Do not read past the story yet. Close the file. Write down in one sentence. This chapter is about this. Write down the brute force approach to the story's problem. No looking. Open the file again. Check if you may have the nice solution. So brute force. What is brute force solution? Brute force is that nice solution where you're using all the resources like मतलब एक ऐसा सोल्यूशन जिसमें आपने सब कुछ ही डाल दिया मतलब आपके पास जो भी है सब कुछ डाल दिया और मत जस्ट टू सॉल्व द प्रॉब्लम मतलब आपने सारी रिसोर्सेज यूज़ कर लिया आपके पास जितनी मैन पावर थी सब कुछ यूज़ कर लिया फिर जब एक बार उस प्रॉब्लम को आपने सॉल्व कर लिया देन यू स्टार्टेड थिंकिंग ओके the the work that I the work that took 10 people to do could have been done easily with the help of a single person. So you start thinking in those directions, like how can I use those 9 number of people, and they can work on something other, like when you are. your productivity has increased. 10 people working on 10 different problems rather than 10 people working on a single problem. So you first go through the brute force. You recognize what's being repeated or what's being wasted. Like what's the waste in this? And then you start eliminating that waste and you arrive to an optimal solution, and that's what we are targeting here. So the derivation, I read through the key observation, mental model, and visual intuition sections. Open diagrams with MD, study the sky diagram, actually trace through them with your finger or pencil, close the file, try to redraw the code diagram from memory. Does it make sense? No. If not, reread and repeat. The output written. Read. Deriving the algorithm and the invariant, copy the implementation. Now, package the without looking at the code. Run it on the small example from the chapter that you could use right answer. If it figures, or you can write it, read again, understand that you already tried again. We have to like keep grinding. मतलब एक चीज का तब तक करना है आपको जब तक कि एकदम आप फ्लुएंट ना हो कि यार भाई अब तो मिल जाए कोई भी प्रॉब्लम दे दो मैं कर दूंगा फ्लुएंसी यू शुड रीच द फ्लुएंसी do these on the code list and start from easy to and cheat dot and the and so we start from readme.md, we go to the exercises.md, then we go to the recognition.md, we come on mistakes.md, and then at the end we go to the cheat sheet.md, and that's we jot down how to go about a chapter, how to go about chapter. But very, very literally boring, deeply understand it, so things on their own, or read exercises that solve the problems, solve them. Then you gotta read recognition.md, cognition.md, and common mistakes.md. And then you already some mistake, think of a piece of code you're written that might work not be solved, then you solve problems, and then read cheat sheet.md and intuition.md. And that's it for the chat. Do nothing else your brain needs time to consolidate. Practice protocol for everything account. You write one line of code by yourself, each function. For legal practice. This is for legal. Write story. Loop code. Raise strategy algorithm and verify. This is people like strategy. History. Yeah. Now I'm not gonna practice it on long because now I'm not gonna read it. Please like if you join. Keep me motivated, helps me, follow along. Yeah, please like the video if you like it. Yeah. So let's start with the foundation. Read it all down. What's the story? In the foundation, how to think about the problem. The story. You are a new warehouse manager at a large parcel delivery company. On your first day, 10,000 parcels arrive. Each parcel has a destination postcode written on it. Your job is to sort them into regional bins so delivery drivers can collect them quickly. and felt it. 1,000 parcels arrived. So again, foreign and family. Each parcel has a destination postcode of origin. The job is to sort them into regional bins so the drivers can collect them quickly. We have five workers over there. How do you approach this? How do I approach this? There are 10,000. Five workers. The postcode. Use the postcode. What's the naming convention for the postcode? So there will be staging in the warehouse, like there is a full warehouse, there is store things. So what would be naive? Like I take one item, go to the warehouse, store it there. That would be naive. I'm traveling all along. Put one item to the destination. That's a large number of travel. And I'm taking single item. Now it's being put at somewhere. I just sorted it out there itself. Like using the numbers. Let's say if it starts with 4, I put all the four, like all the numbers starting with 4 here, or the number starting with 1 here, or the number starting with 2 here, or the number starting with 2 here. Now they are sorted 1, 2, 3, 4, 5, 6, 7, 8, 9. Now all of them are sorted. There could be 1,000 in 4, 500 in 9, like 2,000 in 2, 200 in 3. So now they are sorted. All the parcels starting with 1 are here, all the parcels starting with 2 are here, all the parcels starting with 3 are here, all the parcels starting with 4 are here. So now when I have to store that in the warehouse, I can quickly take out a lot of items from one, just that, like put them into the baskets. So like I have five workers, 1, 2 would be the first worker, 2, 3, 4 would be the second worker, 4, 5 would be the 5, 6 would be the third worker. Yeah, that's it. What it says, worker one picks up the parcel, reads the postcode, walks the entire warehouse looking for the right bin, drops it in, then picks up the second parcel and repeats. Worker two groups all parcels by first digit, then by sub-digit, then by all digits, like sorting a deck of cards incrementally. Worker 3 builds a lookup table on day 1. Every postcode maps to a bin location. So that's what you're trying to do, right? From day 2 onwards, sorting is instant per parcel. 80% parcel go to just 6 postcodes. They pre-stage those bins right at the intake area and only send rare postcodes to the back. Worker 5 reads the postcode, immediately goes to the right bin with zero searching because the bins are basically arranged in a structure that mirrors the postcode system. Every single one of these workers is solving the same problem, but they have a very different intuition about what repeated work looks like and how to eliminate it. Workers 3, 4, and 5 have built algorithms. Worker 1 has not. This chapter teaches you things like workers 3, 4, and 5, not by memorizing their strategies, but by understanding how they diagnose the best waste in worker 1's approach. The naive approach most people take with problems. When most engineers encounter a building problem, they do this. Read the problem, think this looks like pattern I've seen before, apply that pattern, hope it works. This fails in two critical ways. Novel problems don't match any memorized patterns. Novel memory is entirely new. Variant of Variants of familiar problems look similar but require different thinking. The engineer who memorized 200 patterns is little. The engineer who internalized why each pattern exists is adaptable. I don't know who joined, but thanks for joining. It motivated me and I'll keep going. Yeah. Why the naive approach is inefficient. Memorization is expensive and decays. Intuition is cheap and compounds. Every time you understand why an algorithm works, you deposit a small amount of insight into a bank account that pays compound interest for years. It's okay. The safer let the same solution. Not only the I definitely use our infrastructure is the universal problem solving process. This is the background treatment. Every chapter teaches you one more to give you strength. Understand the story. Do not begin with the idea. Begin with the story. Restate the problem in your own words. What does incomplete look like? What does the correct output look like for that? What happens at the boundary? Incomplete and victims of how you involve emotions and when you get this one, understand the story. Yep. It's probably very important before even beginning to script. Hi, 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 hi. Okay, is there any problem with the voice? Please let me know if there is. I will solve it. If you're joining, please drop a hi. Yeah, keep motivated. The struggle is real, but I'm gonna get over it. Yeah. So, the universal problem solving process. Before you even begin to solve a problem, you should understand the problem. That's a very good thing. What is the problem you want? How much you understand? Today can explain the problem in one day. I understand that the right brute force. Brute force is not embarrassing. It is insulting. I've got a tea. It's a tea right now. Well, it's a game. So भाई तो मैं अभी अपनी आज मैंने जॉग मतलब रनिंग की है 5 किलोमीटर और आज से मैं फिटनेस पे ध्यान दे रहा हूँ तो मैंने चीनी भी छोड़ दी है बिल्कुल ज़ीरो शुगर एंड दैट्स गोना हेल्प ज़ीरो शुगर फॉर एटलीस्ट 2 मंथ्स नाउ तो जो अभी मैं चाय पी रहा हूँ उसमें भी वो थोड़ा भी चीनी नहीं लगी है भाई एकदम प्योर विदाउट शुगर स्टॉप द स्क्रीन फॉर अ पिच है तो अभी तो भाई बढ़िया प्रॉब्लम सॉल्व कर लेंगे भाई टारगेट अचीवमेंट पर ही है तो प्रॉब्लम सॉल्व करना ही पड़ेगा तो दिस इज द रूम लाइक जिसमें मैं बैठता हूँ लाइक ये हॉल वाला एरिया है देयर आर टू अदर रूम्स एक मम्मी पापा एक मेरी बहन और मैं यहाँ पे मैं पढ़ाई वढ़ाई और काम वाम मैं इसमें करता हूँ आज मैं जा रहा हूँ सोचो एक लाइब्रेरी है यहाँ पे जाके जाके बैठ के पढ़ सकते हो तो मैं सोच रहा हूँ वो देखने जाऊँगा वहाँ पे कैसा है अभी फ़िलहाल सही है चल रहा है सेशन कोई दिक्कत नहीं है बढ़िया है so understand the story. Do not begin with algorithm. Yeah, okay. Try the brute force. Brute force gives you proof that you understand the problem. You can produce correct output. A baseline to compare against. A source of inefficiency is to eliminate. Never skip a brute force mentally, even if you don't try it out. A reason through expression. Identify the waste. Ask yourself, what is this brute force doing more than others? This is the most important question in the thinking. Almost every optimization computer science is the answer to this question. For a common forms of waste, we scan, working the same part of the array multiple times, decomputing, computing a result that has not changed, ignoring structure, not using the fact that data is sorted, bounded, or ordered, over-explaining, considering options that cannot possibly be. But once you have reached the impossible, that could never be done also. Going beyond that is always going to be impossible. अगर मान लो 2 into 2 का आंसर 4 है तो अगर मैं 5 पे हूँ या उसके आगे किसी भी वैल्यू पे हूँ क्या वो मुझे कभी मतलब राइट रिजल्ट देगा नहीं राइट so if we have if you are looking for 2 cross 2 2 into 2 4 and you have reached 5 what is the point of going beyond that you have to come down to 5 come down from the 5 to reach 4 so the way you understand like you have to understand that अगर मैं इसके आगे जाऊँगा there is no nothing to gain if I move ahead तो वहाँ से आपको ड्रॉप करना पड़ेगा लाइक this is the one that you see in the converging two pointers like there are two pointers here and there left and right so you are computing something and then you realize that okay let's say you are computing a sum is 7 you add right you add left you add right you add and this is a sorted array so 1 2 3 4 5 6 7 like kind of this sorted array you are on the left you are on the left you are on the right you add them and you check them through the target. So if it is greater than target, let's say if it is greater than target, what's gonna happen? If you move left towards the right, like left towards the right, previous number was smaller, now it's larger. So the sum is gonna increase much higher than the target. Do you want that? No, right? You don't want the sum to go even higher. मतलब sum और ज़्यादा नहीं होना चाहिए target से. You want it to be closer than the target and eventually be equal to the target. So what do? You keep the left there, you move the right towards left, so the right is now here. Now you check the sum, it is less than the target. So what does it say? Less than target, I need to increase the sum a bit to match towards the target, to reach towards the target. So I move left here. While moving left or while moving right, what you are doing is you are like removing all the possibilities that you have using that number, that particular number that was on the right, or that particular number that was on the left. मतलब कि इस पोजीशन पे जो नंबर था उससे जितनी भी आपकी वो बन सकती थी, दो नंबर्स के पेयर बन सकते थे, यू हैव एलिमिनेटेड ऑल ऑफ दैट, ऑल ऑफ देम. So you are eliminating that. That's never gonna use the result for you. Each of these strategies will help you. Other, if you're recomputing something caching, and what helps with caching? Uh, Pali. What helps with caching? Or the hashtag, the caching. Hashing helps caching. Move pointers rescaling the same data. That's the same thing. You are going on to rescale the same data. You just move it. Solve first. Other finding faster. Shrink space. Many options are clearly wrong. Like the one that I explained. जब मैंने explain किया left or right to send वाला कि भाई shrink करो उसको, space को shrink करो until you reach a point where there is the sum is equal to the target, or you have exceeded, like the left has come here and the right has come here. So this is not that what that you want. Like the right started here, left started here. They grow across them. Eliminating possible candidates each step. Decompose. Problems as identical substructure. Like if uh, like there is a bigger problem, there is a substring. You are trying to find all the. There is a string. You are trying to find all the substrings. So decompose it in multiple. That becomes like एक बड़ी प्रॉब्लम का एक छोटा वर्जन सॉल्व करो and collectively you will solve the bigger problem. Just a smaller version of the same problem. Like there is a big problem, solve the smaller part of it, and you now know the bigger problem, how to solve bigger problem. Pre-process, like the pre-computation in computer science we call it prefix sum, suffix sum, or prefix suffix. That's it. Many queries on static data spend time once constructed is involved. Like you're trying to, you know, मान लो दो लूप है, मान लो कि एक लूप ऊपर एक लूप अंदर. अब मैं इसको लूप कैसे होगा तो you, the outer loop will run from 1 to n, the inner loop will run from 1 to n. We are computing 1 to n of the outer loop in the list. That waste of a time. We compute it. With a strategy chosen, the algorithm practically drives itself. Ask what data structure naturally supports this strategy. What invariant must hold at every step of the loop. What constitutes a valid transition from one state to the next. What terminates the process. Step 6. Verify. Before claiming you are done, trace through your algorithm number reasoning mental behind. Try smallest possible input. Zero includes one element will lose. Try the pathological case. All same value already sorted, zero sorted. There are time and space complexity. Check the fit. Check if it fits the constraint. Applying the framework or work given. Given a list of daily temperature, find how many days pass before temperature rises above the current day's temperature. What? Given a list of temperature, you are given a list of temperature. Find how many days pass before temperature rises above the current day's temperature. How many days pass before? I mean, I don't understand the problem actually. Like, I have a, I have an like area of temperatures. I have a given temperature. Like, I want to look up like after this day, after the current day, on which day the temperature. at which the temperature pass the current day's temperature. So if I doing a naive approach, let's say I'm quickly going to solve it. I can use DSA temperature ranges. So it's saying you are given an error. Well, people just take it out. Always time, brother. Okay, this is the error. So now, the story of the problem is that at our current day, given the temperature, find out when the temperature exceeded current day's temperature. So it's pretty simple. Use two loops. Less than. Okay, sorry. Less than pair of 11 plus plus. So this is your current temperature. 5. मतलब अभी मैं इसको ये कर रहा हूँ 6 है मतलब if the current temperature is less than ART, what you gotta do result count plus what J minus I equals 1 and break. Here you don't want to go beyond that. First, you need first maximum, first larger value. And you can quickly console the log result is complete. 323200 3 by 2. Okay, yeah, minus I will remove 2 and 2 and 0 0. What is the answer? 211. I didn't calculate. So break. Let's go through it. Let's put a debugger and then debug. So the current temperature for the I equal to 0 is 30 in the block. Scotch.